The old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. Guys, we're going to take a look back on exactly what got me here. Every single experiment that I did. Well, not all of them, but pretty much a lot of them. Thank you, Joe. Appreciate it, man. So I'm going to present today. Hopefully you guys all like it. We're going to look at some high voltage. We're going to look at some Tesla coils. We're going to just look at some random stuff. And in the end, we're just going to start lighting stuff up, man, because that's exactly what I like to do. So let's get to it, man. Let's rock this thing out. So this is my first experiment I did on my channel. I mean, I guess you got to start somewhere, huh? Yeah, just turn the coil around, works in reverse, simple magnetic, nothing special here. It was just, like I said, first time. Just repulsion of magnets, seeing how it worked. So yeah, they do get better. Like I said, you got to start somewhere. It has no pulse when you run straight DC, so you got to turn it on and off. So most of us just use a transistor or MOSFET when you get there. Hey everyone, today I'm going to see how far I can push these magnets here. Hey, just a quick word, cover your ears when this thing starts going off. It whines pretty bad. But it does show you the distance that you could pick up a magnetic field. Those things are 1/2 inch by 1/2 inch by 2 inches long. They're neodymium magnets, 52s, and they're pretty strong, man. So it gives you a good idea of how far the field will go. I don't have any iron core or anything in this. It's all plastic, 2 plastic couplers on the outside. We're looking at a 2 inch by 1/2 inch by 1/2 inch neodymium magnet. There's 4 of them in there. Okay, and they're just run on these little RC motors. I went ahead and hooked to the wall, hacked that thing in there so I don't have to use a battery anymore. And let's see how fast we can get this thing going. And all we're going to do is set this thing. We're going 2 inches apart each time. We're going to start at 2 inches and see how far we can get down and see how much of a magnetic field that we can get on each one and how much it drops each time. So right now we're going to see the RPMs on this and see how fast we can get this thing going so we can judge the speed versus how far we can push this thing. All right, let's get this thing cranked up, going. Close to 7,000 RPM. Let's go ahead and look at it. We'll start at 2 inches and crank this thing up and see how much we get. So we got 3.22. Turn this thing off and then let's go ahead and reset. And I basically built this little thing here, these little hammer in things, and all it is a bolt, 2 washers, and it's a bunch of wire. I'm using .20 or 20 gauge wire on this right now. So basically just trying to see what the field is and how far we can push it. Not so much that we're going to get a lot of stuff off of it since we're putting it so far away, but that's kind of the point here. Okay, let's get going on the second one. We're at 4 inches. Okay, 2.72 on that one. Let's go ahead and get it going at 6 now. By the way, I should have watched where I put the wires for the probe at, because they give you a misreading a little. Okay, 0.065. Okay, well, we're getting lower, but we still got something pushing, so let's go. Just so you know, guys, when everybody talks about magnets, how far they go and stuff, this is a good test. They don't push far at all. That field is very small. Well, and compared to some of the coils we build, they're like 12 inches wide. You know what I mean? This field wouldn't hit the ends of them. So pretty interesting test. Tells you a lot about magnets when you got really strong ones and then you're putting it out. By the way, I'm picking up a little extra energy having that probe way out in front. It should be a little further back. That's my mistake, but you can see it drops off pretty rapidly. There's not much energy beyond this. Coil that Tesla made, and I just wanted to show you, I have it hooked up right now to 19 volts and 2.5 amps, and just to show you what it does, small pulse in there because it hasn't been rectified at all through this little DC thing here. So we're getting the pulse in it, which is good, exactly what I want. Okay, both sides, north and south of the magnet. Here's the magnets we're using in our gravity flyer. And unfortunately, they're pulled from this side to this side and not from this side to this side. So you put it on here and you can barely see it moving. You put it on your hand and you now see it. So we need a little distance here between one and the other. Now, this is a very small thing. Okay, we can flip this over. Okay, to the other side of the coil. You can see it jumping here. Jumping on that side a little bit. That side. So we're okay north and south on this one. Okay, to do the same thing. It doesn't fall off my finger. As it jumps. Now, that's just with the pulsed one. Now, non-pulse, let's go ahead and unhook this. Just to let you know the field on those ones with the holes in them like that have that shell on them, they have a steel shell, so it really sucks. You'd think it would increase the magnet. Not in this case. They take away some of the strength from it. Side, and it absolutely will hate the other sides. Okay, on this magnet here, immediately jump to the other side. This side just hangs up. This side immediately jumps back to the other. So let's look at this one. We hit it, we jumped it, hit it again, top one. So right there, that's what we want. So I'm going to pause it real quick right there and just go back. That little magnet right there, let's just understand this. When we do the gravity flyer test, that one sucks. It only goes in one direction. Everybody thinks it puts out a field everywhere. It doesn't. They put it in one direction only. There is no real magnetism on the other side of it. I mean, you could say infinitesimal amount, but it's not worth the time. It doesn't put out a real field, only towards the, the straight up from it. That's it. They suck. So I don't like them at all. You probably know that by now. Okay, just up my hand here in the garage. So here we go. I'm getting about 1.25 inches consistent out of it. I'd like it to be probably 2 inches, so I'm gonna have to get a bigger driver for it. Hi, you can see. All right, look, this right here, I didn't know any better. Just remember that. This is when I first started. So there's been a lot of problems going on here. So I have a 12-volt power source, probably 3 amps in it. I'm going to a small ZVS. So under the chokes right there, there's 2 little MOSFETs or transistors. I don't know which, to be honest with you. It's been so long ago. And then I go into a MOSFET. I believe it's a Z44. And it ran, and it put a pulse in it. So the ZVS did its job in putting the pulse. Why would I have a MOSFET there? Well, because I didn't know how to run one of these things, first of all, and I didn't ground it out. Like I said, it was just the beginning. This is one of the first Tesla coils I ever made. I was just happy that it ran. Looks like, let me see if I can show you right here. I don't know how well you're going to be able to see this, but we're looking like we're getting 31 hertz out of this right now. We're going to go ahead and need to change that. I think I need to add more coils to my bottom coil here. I need to get that up around 55 or so. I built a circuit here, and what I'm doing is adding frequency. And just to let you know, numbers are way off on what I say on those Tesla coils. I didn't know any better. Those things are at least 1 megahertz apiece. There's just not a lot of winding there, so the frequency is real high. And I did get both of them to work. The Slayer Exciter version that I did with the ZVS and then the ZVS with the DC flyback did both work, by the way. Not exactly probably the traditional way they should work, but I finagled it to work somehow. And then from that, I was able to build this and put frequency into it. Again, must have had some good luck or something on my side because it turned out well. A duty cycle to this so that we can change this on our high voltage. And I just wanted to give you a quick show on the audible difference where you can hear the sound, and then as we change the frequency, you're not going to be able to hear the sound. So this is going to be a circuit that we're going to need to put into our gravity flyer on our high voltage. We're going to have to beef it up because I blow a lot of these MOSFETs. So here we go. I'll plug it in and you can hear it. And then I'll turn down the frequency and you'll hear it differently. So here we are. We're at 2.8 kHz. Can you hear that? Okay. And the MOSFET gets really hot at that frequency. So let's turn it down a bit. You can't hear it now. So usually we're running a lot lower than this, and this is at 745 hertz. Getting what you normally get. Okay, close to this. Now, this is at 50 hertz. We'll go down right to 50. We're a long way from 50. Okay. So Come on. There's 50. We're only at 50% on our duty cycle here. That's about what we normally hear. All we're hearing is the plasma. When we get to 50, because that's the natural hertz that come out of the wall. So let's go back up real quick. And then I'm going to go to the higher hertz. So I'll just read what it says on here. We are going to, let's try this one. We're at 2.90 kHz. You hear the sound screaming? Now, let me just show you. We'll go down to a, come on, agree with me. There we go, 15% duty cycle. And you can see the duty cycle working, okay? Now, I'm going to unplug this real quick. Now, let's take a look. No voltage left on there. This MOSFET's pretty hot. It's the Z. Dude, that Z44 is junk, man. I can't even get one to run these days. I'm lucky it did, and it stayed alive that long. But it did change the frequency of it. When you change the duty cycle, it changes how many amps it gets. So, yeah, there is some things to learn here. But, yeah, I wasn't doing all that great, man. My camera work was awful, by the way. Sorry for that. Tried to use a camera that wasn't good enough, and I should have just used my cell phone at that time. But, again, this is when I first started, man. This is a long time ago. I tried. Oh, this is right here. I was hacking the board. I needed more amps out of it. So I wanted to push the field a little further. So I put another choke on the other side. And it was something I picked up on the internet, and it actually worked fairly good. It gave me a little more oomph in it, which it just meant that it had a little bit more magnetic field in order to give it more energy. But yeah. Okay, I just want to show you guys this. I upped the spark level on this. So just show you here. It's getting better. About an inch and a half now. A lot more. Just real quick, that sound of that voltage, by the way, sounds a lot like when I put on my voltage multiplier to my AC flyback, more than my DC. DC usually sounds a little different. This one starts to sound like an AC flyback with the voltage multiplier. So, yeah, it was something to learn, something that I just saw right now. Kind of interesting. Spark in it. Just to show you what I did here. I bought a new VVS right here. Okay, there were two. I took the center coil out of this one, and I came around here and I soldered it right to the back of this one. So hopefully you can see this pretty well. Right here, the common and the out, I went ahead and soldered a wire between them right there. And then I soldered this on the back right there. And right there to that out. Okay. And it upped the performance. So it went from a 3-wire out, as you can see it here, okay, to a 2-wire out. Okay, which you can see, hold on, you can see now there. So now we just use the last 2 wires on here. I have less windings on my flyback transformer right here. If you take a look at it, it goes, the top one's over, then 1, 2, 3, 4, 5, and that last 5, it goes right under, okay? So, just in case you want to know, you want to up the performance a little bit, you could do this. These were, I think, so I tore it down a little bit, and here's This is where I started laughing, guys. Everybody told me there's little diodes inside of a DC flyback. These are your diodes. Now try to make sense of this. There's a core to this that's magnetic, and wire just wraps around it, so it makes a magnetic field. It goes through these things, what looks like little copper or little mylar on there, and it goes in one direction. Why does it act as a diode? The amount of copper that's on every one of those little clear pieces is not enough to make a heavy magnetic field, so it cannot travel back to the core. It must go in one way. All you're doing is limiting the availability for this to have a heavy charge on it or a big magnetic field. So it works as a one-way diode. Every one of those is connected to a pin on the bottom. So this is your DC flyback. The traditional diodes you may think that's in there, they're not in any way. This is what they look like. So hopefully everybody can understand that.
What I see. There's layers, and that's just copper on there. That's not wire. It's another one. That's another layer. That's another layer. And I got a couple clear layers. And then there's this gray stuff right here. And you can see some wire in there. You know, here I am thinking it's looking like the one I built, and not even close. Alright, well, I keep tearing at it, but this is just something different. Okay, I just wanted to show you guys this is my flyback. I got my multimeter here set on conductivity, okay? And I'm going to find the pins here that we can set this up, and we're going to drive this with a ballast. So you're going to take these in here, and you're going to touch each one. You're going to get a reading, okay? This one's obviously conductive together. This one isn't. This next set is not. No. Right. There, we got another conductive set. No. 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 And no. So we have this one. And this one. This one's higher than the other one. We're going to connect our ballast to these two right here. Okay? And I'll show you that in just a second. Okay, here's our ballast right here. Here's the cables coming out of it. I have three. I have a blue one, another blue one, and a red one. Now, don't let this confuse you. We're only going to use two. Okay, so pick one of the blue ones and one of the red ones. Okay, and we're good to go. Does it matter which blue one you pick? No, it does not. This one just gets capped off, and we'll leave it alone. On the other side of this, we just have hot and common. Okay, this is normal AC wiring from your wall. We're just going to hook it into a plug here. Here we go. This is our plug. We got the cable. Let's look over here. It's real simple. Black goes to black, white goes to white. Okay, there's no ground wire in this one. It's a straight up regular 2. Okay, we go into our ballast. What are we using here today? This is it. Get that number right there if you want it. Okay. And basically we're just going to be putting some higher voltage into this. Okay. So now, what's the next step? We're going to hook it to our flyback right here. Give me a second to reset, and I'll go ahead and solder these two in and cap the other one off, and then we're going to try it out. Okay, so now we're going to solder this in, and you may have a question, does it matter which side blue goes on or which side red goes on? And the answer is no. It does not matter. All that matters is that we solder them in. So, here we go. Solder that one in. It's good to go. Here we go. Make sure that stuff flows right on there and stays there. Okay, we are good to go. Now we're in testing, man. That's it. This is our driver. So let's see if we can make it work. Okay, here we go. We're gonna get this experiment going. We have right here our flyback, our ballast, we have our cable. We're gonna hook that in, and then we're gonna spark it up. We went ahead and plugged in a wire here so that we can check and see which one is our ground wire here. Okay, on the back. So take a second, plug this in. We are now live. Okay. So let's take a look over here. We just gotta find out which one makes the arc. Ooh, it likes that one. There we go. Ooh, yeah. It likes that one a lot. Okay, let's get a little closer. Let's see. Oh, well, that's a cool effect, but it's not what we're looking for. This is a really good one here.
Yeah, there's no confusing it, guys. We know which one's ground.
That one right there. And there you go. That's your ground right there. We're going to go ahead and hook a wire to that, and then we got our spark. All right, we're all set here. We just wire netted our last wire on the ballast. We went ahead and hooked in our negative right here for the bottom. We have both parts hooked into a simple spark gap here. And it is live right now, so I can smell the ozone. So let's go ahead and move it in and get our spark. And here we are. Right there. So it can go out a little further. But that's about where it likes to be. So this is real simple. We got about, what, maybe an inch out of this thing, a little less, 3/4 about right there. I can go up to an inch. But that's it. This is our experiment. All right, so there it is. There's the ballast running it, okay? And then there's your flyback, okay? And there's your spark. Enjoy. Thanks, guys. Okay, say you want to up your game here and drive your flyback here with your ballast, but you want to make it adjustable, okay? Well, you're going to need a couple things here, okay? One, this one right here, this cord's not going to do. We're going to have to upgrade that. We're going to go to a 3-prong cord here. And we're also going to go to just a regular dimmer switch here. And it's got 3 wires coming out of it, your ground. And these are your 2 wires to break hot. So I'm going to reset the camera here. I'm going to show you exactly how to wire this in and wire it into our ballast here, so that we can now adjust how much of the voltage we're going to push through it. Okay, so here we go. We'll just start with the easy one. We're going to detach our hot right here. So now we got 2 hot wires. This is our ballast wire. This is our hot coming in. Okay. Here we go. We're going to take this cord out of the way now. Okay, here we go. We got 3. Okay, make it real simple. First one's up right here. We're going to go ahead and take the white wires and put them together. Okay, these are our common wires. So let's get wire netted together just like that. Okay, our ground wire is next. It's green. We go ahead and go right here to our green wire. Okay, it's on our dimmer switch. Okay. Line those 2 up. Wire nut those together. Now, last one left is our black wire. We've got 2 coming out of here, okay? And this one goes to our ballast, okay? So what we're gonna do is hook one into one and one into the other, okay? This is our hot wire. Just so you know what's going on, we're breaking the hot with a switch, okay? Basically, it just, the hot's hot all the time. It basically interrupts it, okay, with the switch, okay? Now, we could use just a regular switch here. It'd be a lot easier. We could go back to the 2-prong and do that. But this is our setup here. We got 1 black wire here going to our ballast, We got one here going to our cable, okay, that goes into our wall plug. We have a common that goes all the way through, okay. White to our ballast, white to our cord here. We have a ground that goes to our ground on our cord. Then we have a ground that goes here to our dimmer switch. Now we're hooked in. Now let's go ahead and reset and let's go ahead and see exactly how it looks. So what you're looking at is this is my Tesla coil.
Apparently, I cut the video short. It works, and you can turn the power up and down on that with that dimmer switch, and it works great. It's a perfect setup for you. No problems there. Still works to this day. So as we look at this, guys, I started to upgrade what I knew. And you saw my first Tesla coils. They were pretty bare. This one's a little better. This one is the circuit that I still use today. And it's probably one of the best circuits for a Slayer exciter you're ever going to find.
It's been running for about 40 minutes now on the same MOSFET. So I just want to show you a couple things. Let's go in and take a closer look right now. We are at 40 volts. And here's the MOSFET right here. I'll show you what it actually is in here in a little bit. As you can see, I just have a little fan connected right here to it. And just on a heat sink. Cool to the touch. That's cool to the touch. We have minimal breakout at the top. In my case, that's good. I just want to see that it's lighting things up. As you can see right behind it, we're all lit up. So let's go ahead and let's take it to the dark and let's see it. And then I'll push this thing the rest of the way. I believe I only have, what, 50 volts in this thing, maybe 60. So there we go. We'll set the camera right there.
Not bad.
So let's take a look real quick. Get out my tape measure. There we go. We need some light. And right about 8 inches right there. Breaks down. So what we're getting here is we're getting 8 inches that it's really bright. And then at about 20 inches is when it breaks down. And as you can see the lights behind it, we're still glowing. See right there, we pick it up.
So this right here, I wanted to get to a more powerful Tesla coil. This is my first attempt at a ZVS Tesla coil. Let me just tell you, it was an adventure. Okay. Everything turned out okay when I got to the end, but this was really hard on me to learn this lesson. The first time Slayer Exciter nailed it. That thing literally has two parts. It's a transistor and it's a 47K ohm resistor. 2SA1973, I believe it was, or it could be something like that. You'll have to go back to the video. But best transistor I ever used. Kept calling it a MOSFET. I caught all kinds of heat for that. I didn't really know any better. This right here is the first attempt at the ZVS, which later I mastered, but you can see it doesn't always go so well when you first start. Sean laughs at this all the time. It wasn't working, so I turned it up and turned on the heat so I get more smoke. I had it all wrong, man. All wrong. Ooh, let's go back to that for a second. Oh, we're a little far. Okay. When you see the AC coming out and you see the spark coming out, that was literally 5 minutes right before I started a live show where I had to have my Tesla coil working. I couldn't get it, kept having a problem because the Tesla coil, when you set it, it drops in frequency, and I needed to find the drop-off point and then back it off a little, but I didn't know that at the time. I was trying, man, and it was literally 3 days, and I'm on the, on the internet talking to Sean, trying to get this thing to work, man, and I really sucked at it when I first started. So if you do this and you try this stuff, please understand it wasn't easy for me either. You see the setup I have there, and then I completely change it. But I got this thing to really work. So let's go ahead and play it. We'll smoke this one for a second first. Still makes me laugh, dude. I fry so much stuff in my garage when I don't know what I'm doing.
I wanted to give everybody a quick look at my ZVS Tesla coil. It's wound with 32 gauge of magnet wire, and it is on a 4-inch pipe. I have a resonant frequency in my number 2 coil of 320 kilohertz. We're using 1/4-inch copper tubing here on the number 1 coil, and I'm running the ZVS circuit. Now, the only thing I did was take the capacitors out of this slot here, unsoldered them, and then I soldered in 2 capacitors here. So it runs right here. I'll show you the ground from the number 2 goes right here. It goes into ground from the wall. And then right here you can follow the cables along. Here's how we're getting our half bridge on the AC side. And show you this right here. It looks wrong because the diodes are backwards, but it's absolutely right. This is the negative cable going in. And this one is the positive, and yes, it does seem backwards, but it's 100% true. It goes in just like that. And then the other side of that whole cable goes over here to my Variac. And it's putting out AC power, not DC. So we are in AC right now when we run this thing. And I'll just show you here the wave. Here's your normal sine wave. And then here's what we're getting out of it now. We're just getting a half wave.
Now, again, didn't know the answer quite as well as I should have. It should be every other hump on there, not every single one. Obviously, there's a downside that goes down under and then back up. So my mistake. Just wanted to clarify that.
Okay, on a bridge. So normally the wave would come up here and go down here and then go back up over here. But instead we're getting the little humps and we're just getting a half wave. Now, I went ahead and set up a thing here so you can see the sparks and stuff. This right here is where our tip is. Went straight across. That's our base, which is this part's the base, tip, end of the tip here. And I got a scale right here. So what I'm going to do is plug this thing in, and then we're going to fire it up, and we'll see exactly where we're at. I'm going to turn off the lights as well. Put this here in the tripod. Should give us a pretty good view of this thing. I'm going to plug it in real quick. We have about 8 inches, you can hook to 9. Well, we might even be hitting what, 10? Let's see. We're a little warm on the MOSFETs because we pushed it a little bit.
Guys, that was awesome. By the way, man, it didn't come easy to get there, but it was well worth every little bit of it. You saw it like 12 inches. It was getting up there. The thing, it was a little bit hot. They don't tend to run long, but there is a trick to it. If you take a PC fan and put it right there by the heat sinks, you can get this thing to cool down pretty fast. And I could probably run it at 40 volts all day at that, because it'll cool it down enough for it to keep going. Is it recommended to do that? No. This is just it's a fun trick, man, and it came out with some awesome voltage. So, yeah, it really gets going. And the winding I put on this thing is perfect for the ZVS. Now, I said somewhere around 320, but when it's in resonance, it's more like 250 kilohertz. So, yeah, man, it's really rocking. So let's just show a little more plasma one more time. Gotta love it.
So we might even be hitting what? 10? Let's see. We're a little warm on the MOSFETs because we pushed it a little bit. But that was totally awesome.
By the way, I was pushing, just in case you're wondering, on the Variac, I'm pushing about 65 volts right there of AC into this thing. And you see the ZVS board, it's a $30 board from Amazon. The two, oh, God. I can't even think of their names right now. Anyway, all I did was rip out all of the, oh man, I'm really struggling for that word. Capacitors. I ripped out all the capacitors from it. I put in 2 different capacitors, more high frequency Tesla coil capacitors. Cost me about $30 for the caps. Yeah, sorry guys, brain not working today. $30 for the caps, and there you go. So about $60 for a driver. Works great. Probably cost me a whole $1 for the 2 diodes. But the actual Tesla coil, one thing I will say, I tightened up my primary by putting a different base on it, and it's because it was springy. And when it's springy, it loses the frequency that you put into it. So if you put it right to the edge, which is where AC has to be, if it's springy, it'll lose it just by any movement you go around it in the room, anything. So you got to tie down that number 1 coil to every spot so it's perfect and run it. So this is the DC one now. And no, I should not have my power supply that high or anywhere close to that. I have not tried IGBTs at all. Yeah, just real quick, you'll see it later on in one of the videos. Sorry, let me remove this. For the 3D prints for the base, it's on Thingiverse, guys. If you go back to the video where I showed it, I believe I have a Thingiverse attachment on there, a link on there, and you can get the new ones. These are the old ones. I put the new ones on there, man. The new base rocks, yeah. You can just put it on there, man, and it holds everything perfectly tight, and it sets the frequencies beautifully. But you can see in this test right here, what I'm doing is checking the DC on it. This is close to the same frequency. We're 10 kilohertz different than the other one. And I wanted to do it in 28 gauge instead of 32 gauge. So it changed the size of the Tesla coil quite a bit. This one's closer to 2 feet. The other one's closer to 1 foot, but it still pulls a good distance there. I mean, that's not bad for what, 30, 20 volts, whatever it says on there. That's pretty good.
Sometimes when you want to let loose, it's...
All right, sorry. Man, I got to put little dividers in here. All right, guys, now we're going to get into it a little bit. I'm going to go through my channel and just pull out some of the best stuff I did on plasma and show you guys that. And let me just tell you, it's awesome. I love experimenting with it. And let's get to it.
Sometimes when you want to let loose, it's time to just let it all hang out. So what do I do for fun here on this channel? Well, I light things up. That's what I like to do. Not with fire or anything like that, though sometimes fire does happen. But I like high voltage. And I like to run projects with high voltage. I take a simple ZVS and a flyback, and you can't believe the amount of experiments I can do with this, create beautiful plasma arrays, and then just create absolutely frightening voltage. Anyway, let's take a look, man. This is one of my funnest things to do. I was kind of bored today, so I made this. I was just waiting for parts to come in. Anyway, I got these little voltage modules from Amazon, and I hooked them up in a kind of a star pattern here. And then I put 3 AA batteries to it. So let's go ahead and take a look and see what it does here. I need a little more voltage than meet in the center. Just cool. That's only 3. That's all it took. You fried. Anyway, that's it. I wanted to see what would happen if I took high voltage modules, turned them on.
Sorry, guys, there's no talking over that. That thing is loud, man, and it's even worse in person. But this one gets pretty good, too.
On, and then run a flyback spark right through it. The effect was really awesome.
There's the fire.
I like the fact that this thing started out really calm, and then it just hit, and then it hit again, and it just lit up the whole room, man. It looked cool, and it sounded just gnarly. Those were absolutely terrifying experiments, but let's get back to the flyback now. I'm going to show you several different ways to drive this thing. I hope you enjoy it. I set up 3 different flybacks here with different setups on how to use them. This right here is a ballast setup. It's on a dimmer switch. Ballast, ZVS. Okay, over to our first spark right here. It's connected to the back right here and on this. Okay, where normally you would connect it. The second one here is a battery connected to a ZVS to our flyback. Okay, and this is going to the second one here. This is our third setup. This is ZVS to the flyback. This is right here a power pack, 19 volts, 3 amps. Okay, and it's going to our third spark. And basically I just want to show you the difference. In this setup, if you put a second flyback in series with it, you can get it down to a static volt. Basically, you're putting in 3 amps, you're getting like milliamps or less when you do a second one. But we're just gonna go with one for right now, okay? And I wanna show you the difference in how they look. This is the ballast setup right here. You can see the ion wind, you can see the plasma pulling a little bit before you can see the thickness where the amps come into it. Not very strong, but it's a pretty good runner. The one on the bottom, you can see that's the one with the power pack. The one in the middle is the one with the battery. You can see the middle one flaming up a lot. The one with the power pack barely crosses over the spark gap there. So you can see the distinct difference. This is the one connected to the battery, and you can see very clearly the amps in it.
By the way, guys, there's no getting around that. When you power them differently, they have different powers coming out. It could be the same exact DC flyback that you use. It's really good no matter how you power it. When you put a lot more amps into it, you're going to get a lot more white, and that whole spark gap's going to open up quite a bit. When you do it the other way, the cool thing is 2 DC flybacks in series with that power pack, by the way, was my favorite power pack before I blew it up, make the most beautiful displays of plasma because it's static. The ion wind is amazing. I've never had anything replace it that was as good as it. So yeah, it's awesome to see how each thing works.
Amps is the white part. When you see just the purple, when you do the spark gap, that's usually just telling you the volts. When you see the amps, it'll come out in the white. So you can see as I pull it apart here, exactly how many amps are in this thing, and it's a lot. This is the one hooked to the power pack. As you can see, there is a lot of purple in there, not a lot of white, so it's very, very low amps, down to milliamps on this one. Today I'm going to talk to you guys about how to make plasma, the circuit to do it, and what you need to look for. These are the plasma projects I'm going to show you how to build today, and I might throw in a couple extra. But here we go. Let's talk about what kind of plasma and how you want to make it. If I want to make something with a lot of amps in it, I'm going to go ahead and use this power pack here. It's designed to put out more amps. But say I didn't want to do that. I wanted to put out less amps. I'd use one of these. This is just a simple power pack. You probably have one laying around your house. Pick one up at a yard sale, or you just want to buy one. This one right here, 12 volts, 4.16 amps. So this one right here is fairly good for the plasma array that you see that spreads out, and I'll show you that. This one right here is 19 volts, 2.37 amps. This one is my go-to on most of my projects that I use for the plasma feature that spreads out. Now, if I wanted to create something with a lot of white in it, then I go ahead and I use this. And actually the voltage turns pink at night. So it makes a real cool look. So if you want to use heavier amps, there's this. Lighter amps, there's this. Now I'll show you the difference in the actual voltage, the way it looks real quick. This is the voltage coming out from a power pack. As you can see, the voltage is real thin. It doesn't have a...
By the way, Sean's making me one of those Death Star Tesla coils. I want to do this exact experiment again, but I want the breakout from the Death Star Tesla coil on my fingers, just like this. Now, these are coax cables, so they hold in everything. So they're really good at this. Now, when we start shooting out something that's 12 inches long from it, I don't know how much is going to come back at me, but this is a test I want to do, man. You got to have a big pair to put that thing on you and do that.
Whole lot of white in it. Perfect for making plasma that sprays out in that cool looking effect. I wouldn't recommend you do this at home unless you want to ride the lightning. So you might ask how I set this stuff up. These things are generally pretty simple. If you look at this, and I'll show you a good picture of it, there's a positive and negative on it. All you have to do is line those up with your battery. I put these little ends on here. I'll show you a better picture of that. And it's a simple wrap around your DC coil here. Probably had a little more zap in it. Anyway,
right here, the positive and negative. I've had these things where the amps are so high on this side, this little bracket here, it just burns right off. It unsolders itself, and then I had to solder directly to the board itself. So keep that in mind. Now on your negative, it's just the one that sparks the best. I'll show you a picture of that. It's actually pretty cool when you do it. It's a little fun adventure just to have, because maybe you just want to go out and spark something. I do that. Matter of fact, I do it a lot. But anyway, I'll show this better for you, but this is one of the setups I use. This is one of my voltage coils, so you're basically going to see this one with the, you're going to see it with the battery right here. So that right there is what's going to create your pink plasma.
All you need to do is get your ZVS set up here with your flyback. Okay, and all you're going to do is you're going to put, this is an aluminum ring. You can use steel, okay, it won't matter, or copper. And then you're going to take a hole saw and your drill. And all you're going to do is you'll end up centering up the drill. Make sure you tape off the light here, okay, so you don't get that in the background because it makes a very bad image. Then you're going to take your wire here. Mine's all kind of funky hooked up to this big old cord that comes across here. And all you're going to do is you got your negative over here. This will be your positive. As you hit the drill, just place that on there as you're holding the drill. Now, pull the drill out before you stop it, because you'll get a little bit of a shock depending on how much your ZVS is going, because there's a lot of static going on. Put that right there and make a ring of fire, and I'll show you how it looks. So what I want you to notice right here is you see that the power pack was hooked up earlier, and it puts out a lot of amps. As you see in the plasma here, there's a lot of white, and yes, it does go into pink, but all that white is the amps in the plasma. That's why this one works the way it does. Again, distance, we are probably about...
All right, at this point, guys, you have to notice it. I'm telling you that there's a lot of amps in there, and it's changing colors. I'm telling you, when there's not a lot of amps in there, it goes to a different color. There's a pattern here. So every single time you do high voltage, you have to look at how many amps it is. That's basically the magnetic value in that DC flyback transformer. So there's a correlation here between light and the magnetic field.
About an inch and a quarter on this one, because we're not looking for that big giant plasma effect. We're looking for like amp and plasma effect.
This one right here is the one I use to create most voltage projects. The actual flyback in here is a little different than the other one, so I'm getting a much thinner spark, which is exactly what you're looking for. The thick ones with a lot of white in them have way too many amps. So this is the one I would use the power pack on. Again, I'll show you a better picture of this. As you can see, there's no piece right here. Again, I had to solder it to the back because I overamped it with a different power source than I usually use. But this is the coil that I go to right here. Again, here's the power pack that I use here. And just as a quick understanding, I'll show you this a little better. Oh, anytime you use one of these right here, just remember this right here with the shielding on it of the plastic is your positive. Anything right here with just the metal, it forms around the whole thing. You got to pull it to one side. I solder mine off. That's your negative. One of my favorite things to do with plasma is to connect it with these items here. Now this is just a solid piece of aluminum all the way through. These right here are just saw blades. They were once one blade, pretty big, just like that, used for cutting tree limbs and stuff. Anyway, what you do is you connect the positive here or the negative, doesn't really matter, they're both positive. So just hook the one you think is positive here, the one you think is negative here. Right about here, you're about 1.5 inches off. That's about exactly where you need to be. Sometimes a little more, sometimes a little less, but that's where you need to be. And that'll create that nice plasma bridge you see right in between it. Now,
you want to get a little more advanced. You take this and this and you set it up in this configuration here. Now, what are you doing? This has to be connected to this one. So these two are connected on the same line. This is connected on the opposite. So if you said these two are negative, this would be the positive wire. Again, distance is important. Now, you may think, well, you're using two, so you need to bring in the distance a little bit. And the answer is no, not at this level. Just right here. This is exactly what you need. So that'll get you this nice plasma look here. One thing to remember is the sound you want to hear. When you hit that sound, you know you're at the correct distance. Maybe you want to do it in saw blades. The key here is metal, no paint. This is a used saw blade, plenty of metal on the ends here. So what do you want to do? Same thing. If you connect it with this right here and straight, you're only going to get the one where the distance matches right here. So obviously that's just this. What do you have to do? You have to bend this around the curve to match the saw blade. Now, can you use two saw blades sitting on top of each other? The answer is yes. And all you have to do is you line up the two saw blades here. Again, two, line them up. Again, put this piece over here and it'll give you the same plasma look. Everything's about a big size and a small size, no matter how you do it. One has to have more mass in metal. That's the key here. And no paint. If you use something that has paint, it's not going to give you that same plasma look you're looking for. It'll actually maybe just spark over once or twice if you're lucky. Or it might just do nothing. The key is no paint. Has to be bare metal. That's how you do it. This is what the saw blades look like when you connect it to the rod now. And you can see on here I bent the rod. And I just want you to look at each one of the little ends of the saw blade here, the little points. They actually make the plasma come right off of it, and that's what you're looking for. Couple of things here. If I just wanted to use a hole saw and a ring, could I do it? Sharp edges, again, metal. Everything depends on distance. As you can see here, the aluminum ring is about 1 3/4 inches or so away from the bottom hole saw blade. I didn't show the connections in this one, but obviously the ring is positive, and on the bottom the hole saw blade is negative. From the side, this just looks like a bowl. From the top, it kind of looks like a vortex. Just to show you, you can use just about anything for one of these projects. This right here is my big speed square. This right here is the same saw blade you saw earlier. Now, I can put this on this side right here and create plasma in between it. Why? Because this has more metal in it than this. And again, sharp edges and no paint. This right here makes this effect right here look cool, just like this.
It's so cool. Plasma is just beautiful.
This right here is a pretty cool effect. What's going on? I have positive on one side, negative on the other, and all I'm doing is converting small to big, and it's sending ion wind down to the other plate. Now, if I pulled it back just a bit, it would just create charge on the disc. This way it converts it over. Just so you're aware, every time it sparks over, it loses charge on the plates, and it has to start over.
Okay, look. This is one of the tests I did on my gravity flyer because everybody told me it's ion wind. Let me tell you right now, I know it's not. I've done this a million times. There's barely anything coming off of there. 2.4 meters per second is what you're getting. And it's not very much, but the display is beautiful for plasma, though. Every sharp point that's on that smaller disc will create an opening for plasma to come out of it and go onto the bigger disk. So, yeah, it's pretty cool, man. But ion wind is very weak. Even with the amount and rotation and all the extra things you add here, still not going to work.
I just wanted to show you guys this build real quick. This is a 1000-watt ZVS. This is a DC flyback transformer. And this is a second DC flyback transformer. As you can see, we have...
Oh, real quick, this is Plasma Channel's build. He did an ion thruster, if I'm not mistaken, on the one this is. Should be. And I went ahead and made the 3D prints. It's on Thingiverse. So if you look this up in my channel for ion thruster, it'll come up. And the the STL files for this are on there, and you can get them and make your own. But this is pretty cool.
I have 7 wraps on this and 7 on this one. Now the one that goes over top, I put it on this left one here, output B. The one that goes under it goes to output A, which is on this side. Okay, and this right here connects here, and it connects here. This top one here connects here and here. This is run really simple. The hot wire that comes out the red one right there, it connects over here to the ground that goes into this one. Then we have the hot wire that comes out here. Okay, and then that one goes right here to the ground and they spark across here. Now, let's go ahead and take a look real quick. This right here is the schematic for it. And as you can see, we have a power pack on this one, 19 volts, 2.37 amps. Goes to a ZVS. Pretty simple, plus and minus are shown. This right here, exactly the way I showed you it comes out. One wire here, same wire goes into the bottom here. This top wire goes in there, goes all the way, jumps this one, and comes over to this one here. Again, red wire into the ground right here. And then we have the positive that comes out of here, makes the spark. Here's the negative up here, comes all the way around. Pretty simple circuit, easy to build. Okay, let's go ahead and see. I'm going to go ahead and turn this on, and then I'm going to turn off the light so you can see the spark a little better. But hopefully you'll be able to see this. So maybe I should move this wire closer. I'll just move this. How about that? These wires, they never want to agree with me. Yeah. Right there you see the spark. I want to show you this. Whoa! Crazy stuff going on. Wires moving everywhere. Watch out not to get shocked.
Try not to get shocked. Yeah, that happens more than you think.
Alright, now we turn off the light. Let's go ahead and take a look at this. Look at the ends. You can already see them lighting up right there. Let's bring it a little closer.
Fire.
And yes, I do have fireworks going on behind me on that one.
Hold on real quick, guys, just so you know. A little bit of fire isn't going to stop me. We're building high voltage here, okay? It's going to have a little fire once in a while. I'm not getting discouraged. I'm just going to keep pushing on. God knows I fry so many things, but it's worth it every step of the way to learn just one little thing.
See it coming together? Let's see. Right there, that's what I want. See that? That purple? Perfect. That's why you build them in like this, with 2 of them together, because you want that right there. And yeah, I do need to replace that that transformer. It's bad. But you can see the spark. Get closer, it sparks out. A little further, you get the ion wind. Exactly what we're looking for. Is a perfect setup for that. Alright, let me turn this off without trying to zap the living daylights out of myself.
It does it to everything. Oh, man. I should really get some setup to hold that.
Okay, we got the lights back on now. I just want to show you this. This is my ion thruster. This is the reason why you would build one of these. So all we're going to do is I'm going to take this positive here and I'm going to connect it to the top wires. I'm going to take the negative right here and I'm going to connect it to the bottom right there. Okay, I'm going to connect this up real quick and see if we can't get a better shot. There we go. Sorry, it was on my foot. Alright, there we go. It's a good shot. Just want to make sure there's no miscellaneous wires hanging off of it. We got this one here. I usually wrap it around the top. This is just for testing, guys. So you can get a look at what we're doing here. Here's our negative. Anywhere on the bottom here, they're all connected all together on the bottom. All the wires are connected into one. So you can just hit one on the negative there. And then let's go ahead and see if we can't move some stuff out of the way. I'm just going to set this right here and get this wire out of our way. Okay. There we go. Let's just make sure the circuit works. And then we'll turn off the lights again. There we go, I can hear it. Alright, I'm going to go turn off the lights real quick and you can see it. Let's see. Probably have to turn off the TV. There we go. You can see it right in there now. Look at that. Now this one's kind of beat up. I've been using it a lot. You can see every point where there's a sharp point, it breaks out. So there's ion wind coming off of it right now. So this is what that circuit could do, and I got a busted transformer that's starting to burn out on me and it's still producing this. So it's a pretty good circuit if you want to run it. I have the STLs for this right here, or the 3D printed files where you can make your own online. I'll go ahead and put the link in the description for you. But I just wanted to show you this. It's a pretty cool setup and it makes some pretty awesome ion wind. I wanted to show you guys this. Look, this is the top of the thruster at night. You see all those little lights, or like, I don't know what to call them. Everywhere that you see them is where my razor blade went over the magnet wire to make it bare. So you can see just the total amount of ions that are pulling from there only. The rest of the magnet wire doesn't do anything. It's just this little bunch, okay? So if I probably add more, okay, I can get a little bit more, but it doesn't add in the amount that it comes out, right? So we're getting what, like 2.3 ms out of a regular thruster, but by adding a second wire, and you can see it in there right there, so it's 2 right there, and then it goes down to 1 bar in the middle. It did add volume to the total amount of air coming out. So we added more air coming out, okay, which will eventually give us more thrust. But, okay, we didn't change the amount coming out. So I hope you understand that. Just give you a better look. Make a really nice light show if you're watching it. You can
Look at that. That's a lot. When you do this, you have to have it really dark in the room to see it. You have to play with your lighting a little bit, backlight it a little bit in order just to see all that ion wind coming out. But yeah, open the garage door after this test, get it all aired out every time, man. It really is an awesome test. You see just a total cloud there now. It used to be real thin. I didn't show it the other one at night, but anyway, comes up real nice. Just thought it'd be cool to show you that. It's a really, really neat thing to see at night. In case you were wondering how much air was pushing out of this with the ion wind, 2.4
meters per second is about what I got. And on this one, it's not hooked up in double form. It's just a single one blowing at this time. And as you can see right here, turn on one last time, 2.4, it jumps up to 2.9, but it's more of an anomaly than the 2.4 consistently coming out of it. But once in a while it gets there. Here are some high voltage experiments that I did. Here's the first one, voltage walking.
Light it up. Looks like a little guy's legs running.
Here's the second experiment. I call it pins and needles.
Why not? It only does one at a time, though. I was hoping for all of it.
This is the third experiment. We've all seen voltage on a round magnet. This is what it looks like on a rotating magnet.
Those magnets were dead when I was done. They weren't any good anymore.
Just in case you were wondering, yes, I did demagnetize those magnets, putting them in the high voltage field. Those went in the trash.
Sacrifice.
So if you want to find flybacks and you don't know where to look, this is a CRT TV, or otherwise known as a tube TV. And yes, there's a flyback in here. But the question is, do we have to rip it out, or can we just use it as is? This is a spark gap for a CRT TV, or basically a tubed TV. It's a 27-inch TV. The positive gets connected to the flyback transformer. The negative gets attached to the strap on the TV. It also has a connection to the motherboard, which I'll show you later. And yes, I do have to clean it. That's probably just all the garbage on there smoking off.
No, it wasn't. I was frying something. That was not the garbage smoking off. Just keep going. Keep frying it.
The spark gap on this gets pretty big, but you have to start it real small. As you can see, we're about 1 inch away when we start. We get up to about 3 3/4 inches on this thing. Pretty decent spark, pretty good on amps. It's not as light as two flybacks together, so it's got a real thicker approach to it in the beginning, and it thins out as you pull it apart. I wanted to see how strong it was, so I also tested it on my thruster. So the measurements are 3 3/4 or 95 millimeters. The negative connects to the motherboard right here to the strapping. The very last thing you have to do is connect the positive to the top of the flyback. So this is just one of the first of many power sources, and I'm going to keep trying to find a better power source for lifters and things. At this point, I'm not too encouraged with this. It's going to need some modifications to do right. I built this double helix Jacob's ladder,
Cool.
and it looks pretty cool. The high voltage goes up it and spins around all the way until it explodes out the top. Anyway, this is how you build it. So what I'm using right now is a 1000-watt ZBS driver, a 24-volt battery for my Craftsman drill.
Did I burn it up? Oh, you bet I did. So first of all, I burnt the driver. So I burnt the transistor that was in it. And I said, oh, well, let's just go ahead and take it out. Then I took the DC flyback out and used it for other experiments, and it's dead now. These things aren't there to last forever, guys. Not the way I run them. As soon as you create a spark, it's pushing pressure back to the flyback, and it'll eventually kill it. But, man, do I get a lot of cool experiments out of them before they die. So, yeah, just keep pushing on, man. Keep burning stuff up. See what they do. This is the only way we get to learn exactly what energy does. My driver on this one, I've went through about 4 of them over a year. That's not bad. Those drivers are pretty sturdy, man. They're pretty good.
I'm also using a flyback DC transformer, and then the actual metal here is just twisted around a pole. As you can see, you do one and then the other, one then the other, all the way up, just like you're braiding, and it comes out pretty cool. You get it to the top, you'll have to adjust it a little bit just to make the breakout point where they don't touch right away. And at the bottom, you need to bring it in close enough that they touch enough, but still let the thing drive forward and go up. This is my first attempt at making this. It actually turned out pretty good. There were a few sticking points on it. They kind of held it up a little bit, but it went up pretty good for the first time doing it. The distance on this all the way up is about 1 inch apart. It's important to maintain that distance all the way up. You do not want it to spark early or die out on you. So the distance is important. Also at the very top, you have to have it a little bit wider, or else it'll just start at the top and it won't start at the bottom. So just maintain your distance and you'll be all right, and it'll break out at the top.
So you asked, what's the driver? I just use a simple ZVS driver from Amazon. I prefer the 350 watts if I'm doing plasma displays to create the beautiful bridges and stuff. If I want sparks and I want a little more amps in it like this, I like to use 1,000 watt. Now, if you rip off the capacitors on it and put a Tesla coil capacitor, your frequency goes to the roof, and it makes a beautiful display with that one.
As you can see here, I cut it a little bit shorter. I think it comes out a little better this way. Both effects are cool. You could do either one. I just wanted to show it a little bit shorter here. I think the breakout on the top is a little better. The reason it doesn't go all to the top all the time is because I have to put in the power manually, on and off like that. It's not reciprocating like it probably should. So I'm going to have to look into that and see if I can't get that right. Otherwise, I'll just put something on it to make it go intermittently like that, like a switch or something like that. Maybe I'll do a MOSFET for on and off on this thing. But you can see with the shoulder, it looks pretty cool.
You know, sometimes you just get bored, so you just try things. So I just have a coil here and I want to put a spark cap through it, and well, let's just see what it sounds like.
So originally I was going to build this thing as an atmosphere motor.
Okay, by the way, this goes terribly wrong. And before you say you could make it work, it completely melted before I was done, man. So, yeah, this is a fun one too.
And well, I failed. So I decided to just hit it with a lot of high voltage and see what it looked like. And well, you could see that it pretty much is starting on fire. Yeah, that was fun.
You know, you just can't win them all.
Looks so cool though.
Most people see this experiment as a can being moved by static electricity. But did you know high voltage can do the exact same thing? Here is the static electricity experiment. It just works on a simple principle. Take the cloth, rub the rod, and it'll move the can. Static electricity does the rest. Now let's use some high voltage, and let's see if we can't get the can to move again. As you can see, both effects have worked. Why? Because we're polarizing the can. As you can see here, I sanded the can down. Why?
Okay, guys, by the way, we're in an AC flyback with a voltage multiplier now. That thing, I've never had it die yet. that AC flyback is the best one I ever bought.
Just to show you that the high voltage is actually on and it's working well, let's go ahead and turn off the lights and see if we can't get a little plasma now that the can is sanded a little bit.
So real quick, why is it sparking now when it was moving the can earlier? And it simply has to do with this. By moving it in and out, I was creating a pulse on it, and it was making the can move. And it's running on eddy current. It's just forcing it away from the magnetic field on the saw blades. But here, you put it immediately close to it, and it starts to spark. So it changes the effect. So just so you understand what was going on here, I didn't change the driver. I didn't change the voltage. I just changed what I knew about it and switched it.
As you can see, the high voltage works just fine. We get a great plasma out of it. And yes, I do need some new wires. They have cut open with the high voltage experiments, and they seem to blast plasma everywhere. I'll tell you what though, it does make a cool look with that wire being messed up. It actually shows you just a stream of plasma coming off that thing. For those of you who are doing high voltage experiments, you should really understand this simple fact. When you thin out the voltage and remove the amps, it acts just like static electricity, and it polarizes things. In this experiment, we just use a simple can. Whether it be from static electricity or from the high voltage, it has the exact same effect. As you probably noticed in the last video, I switched from a DC flyback to an AC flyback with a voltage multiplier on it. You're probably wondering how I did that. Well,
okay, real quick, I just got to tell you this. This is in negative. The only difference between this and a positive one is the direction of the diode. So if you flip the diodes the other way, it goes positive on you. Just understand that and make sure you flip your power source accordingly. I ran everything in negative. If you try to do a lifter in negative, it won't work. If you want to do a lifter, it has to be in positive, just so we all understand each other. So I put negative on this one.
Here you go. I'll show you exactly how to build it. This project is extremely high voltage, so please follow every safety precaution you can if you build this. All right, let's get into it. I just wanted to show up front, this is our schematic that we're going to use. Don't worry, I'm going to show it again later and explain it. This is a voltage multiplier that I've already built, and I just wanted to take the time to show you the back diodes. It's important the way they go in. On the front here, we want a clean look. We just want to space them out evenly. We're going to start here with our plain prototyping board. Again, this is not the green one. This has no metal in it. It's just a plain board. This part right here is pretty much up to your discretion on how you...
Okay, guys, I did a whole video on this if you wanted to check it out. I didn't want to really bore you with this too much. But it's important when you put all this stuff together, keep even spacing and try to take out all the sharp edges that you can. It makes a big difference. This is the same one that Plasma Channel used. And again, I wish I had put it in positive because it would have been easier to understand the first time I ran a lifter. And the board itself, do not get the green one with all the metal in it. Everything sparks over. You do not want that. Okay, let's see what it does.
Now, the other side is this far side. These two are communication in the center. and that's our negative right there. The white was our positive going on this one. So we have it there. We go to our flyback right here, AC flyback. You can see it goes over on the bottom side and under on the top side. Again, 2 wires coming off. Exactly what we got here. Then we go ahead and look each wire. They're both connected to one side. So let's take a look now. Here we go. Here's our multiplier. Here's our sketch of what we want to do. Again, you see the ground on the right side. Power coming out of the single. So let's see. 2 wires here where this wire is. Power on this side. Ground on this side. We look at it coming in. And now we got our spark. Let's go ahead and turn this thing on. Let's see what we can do.
There we go.
As you can see, we all work. It looks good. I like it.
We're going to build voltage across 2 capacitors here. The top one is a paper plate capacitor, and the bottom one is just a small disc capacitor. Now you see the aluminum foil over the sides. It was because I wasn't getting the effect with just the capacitors alone. This video was actually requested by someone who watches my channel quite a bit and comments a lot. This is for you, Obi-Wan. You can see the voltage goes right across the 2 capacitors here. The outside is a little longer on the top plate, so that's where it's going to spark across. When you put them flat, you don't get much of anything, so you have to have some kind of a spiky edge on the side. And it just sounds terrifying. How cool is that? Let's go ahead and take a look at this at night, because it's really so much more of an awesome effect.
So, real quick, I just pause it. I know Sean's watching. AC voltage with DC pulling out. So you see all the little tendrils there. So it's not quite the same as what he gets. Totally different setup than his Tesla coil, but you can start to see it comes out. And those might be AC tendrils and all, but it kind of looks the same. You get the fuzz, you get the field, and it looks beautiful, but then every once in a while it just sparks off like lightning. Yeah, it would be cool to see this in slow motion. I wish I had the camera back then to do it. I'll have to do the experiment again.
You kind of see it bouncing in here. It's because every time that you see the purple in there, that's the high voltage right there, and it puts off an ion wind, and it's actually blowing the top part up. It's just on a flimsy stick, so it's easy to maneuver with this. So the question you must be asking by now is, are the capacitors doing much in this? We know that we get high voltage sparks like this on regular foil, But what are the capacitors doing? The capacitors themselves are just amplifying the amount of sparking between the two. Normally, this takes a little bit shorter of a distance to get this kind of arcing, but the capacitors themselves make the arc a bit longer because it holds it and then drops the spark. Holds it and drops the spark every time. I wanted to show these photos again. I just want people to understand. People think the sparks only come from one side. They actually come from both. One comes from the top, as you normally see in this, and then some come from the bottom. So you can see that in these two pictures here. If you look close, there's two voltage spikes that come from the bottom. Our Earth works.
So look at it on the right side. You see that one? There's a gap there. It's about a 1/4 inch. It's coming straight out of the bottom. It's not coming out of the top. So, like I said, there's a capacitor on each side. So it's layered. It's one plate, aluminum foil, another plate, aluminum foil, just like that, like a high voltage capacitor. Same thing on the top. And it really changes some things.
The same way. We see the voltage coming from the sky, but rarely people know that voltage actually comes up to meet it. So it just started to break daylight in my garage just a little bit. And I wanted you to see this because the plasma that comes out, you can see the glow of it. And then it starts sparking off. But then you see the glow again. I think in the future what I need to do is just stabilize the top plate and the bottom one, and I bet you I can get a nice plasma glow at night.
By the way, when you put quartz crystal on high voltage, it doesn't actually go through the crystal. It just goes around it. So I would love for that to work, but I haven't found that it works at all yet.
What you see is the plasma breakout on the side here on the foil, and it's going to start to make that alien sound again. Beautiful plasma arrays are easy to build, but how do you get this effect and avoid this effect? Yeah, just sparking over like crazy. And then what's going on during the day when you can't see it? Is it still doing the same thing? Yeah, it is, but you just can't see it because it's not nighttime. Let's take a look at how it's done. The first thing we need to do is just set this thing up. So what we're looking for is the saw blades to be equal distance from whatever object we put in the center. In this case, it was just a double helix project I had left over. So what I did is set them equal distance apart. They're about 1.25 inches to 1.5 inches away from the double helix. And what it does when you move it too close, it starts to spark. When it stays far enough away, it hisses. And then if it's too far away, it won't do anything. Once you have the hiss, turn off the lights and you'll get this. Let's take a look at this other project. I built a coil around a all thread, and I was trying to get it to spark around in a circle all the way up. The voltage doesn't work that way. I went ahead and changed the coils just down to one coil so that you can see what it actually was doing.
By the way, every time I hit that, look at the camera distort. That's some high voltage, man, and it just sounds terrifying in person.
On this one, I just offset the coil a little bit. So down to 1 coil. Turn off the lights and you'll get this. Turn off the lights and you'll around a all thread.
All right, rewind
And I
a
was
little
trying
bit.
to get it to spark around in a circle all the way up. The voltage doesn't work that way. I went ahead and changed the coils just down to 1 coil so that you can see what it actually was doing. On this one, I just offset the coil a little bit, so it'll go high and low. Here's the power source. Here's the battery right here I use for my drill. This is a 1000-watt ZVS and an AC flyback. And this is my voltage multiplier circuit. The negative of the voltage multiplier circuit goes to the all thread. I put it underneath so that it doesn't come in contact with the positive. The positive goes over to the ring itself. Once you connect all those, it's time to light it up. If you're wondering how I built the voltage multiplier or the circuit itself that you just saw, I will add a video to the end of this one and you can go ahead and watch it, and I do the complete build on it. I wanted to show you 2 more things here with this coil that I thought were really cool. This one here, when you put the voltage into it, you see it sparking over. You can also see the lights coming out today. It's no longer nighttime. So you can see just barely some plasma in there. But the coil does move as you turn it on because it wants to roll towards the saw blade. You're probably wondering the other experiments with the coil, if you get something down the center, can you get it to light up? Well, yeah, I could. Unfortunately, the lighting outside just got a little lighter and it changed the effect, but it looks cool. As you could probably tell with a lot of high voltage projects I do, I use these saw blades because they are just awesome for putting out plasma. So I wired these all together. See if I can't get them all to spark.
Let me just give you the warning now. Do not do this at home. It will not end well. Dude, I was laughing during this entire experiment, okay? But I don't know why, but I did it. And oh my God, just don't do it. Trust me.
Spark at once. I saw a guy on the internet put these between his legs and fired them all off. I'm going to give it a shot myself. So I got these 2 batteries here hooked up, and I'll just show you what it does. Yeah, that between your legs. All right, it's going to be fun. Remember when your mom told you not to do stupid things? Yeah, this is one of them.
I know this is terrifying for most of you, but honestly, I just couldn't stop laughing the entire time it was
Stop
going
laughing
on.
now, it's funny.
Man, some of those plasma displays, man, they're just gorgeous to look at. But then some of those high voltage ones, man, they just rip right through there and they're scary as heck. Man, I really do enjoy doing this. I mean, when you really want to blow off some steam, light up some plasma, man. You know what? I really had a great time doing this. I hope you guys looked at all the experiments and enjoyed every one just like I did when I made them. Anyway, if you like what you saw here today, please like, share, subscribe, do all those fun things, and have yourself a great day.
All right, man. So, guys, that's just awesome. So hopefully you guys understand my journey now. Most people that come on here just see that we talk about anti-gravity or things like that. Look, man, I do a whole bunch of investigations, and this is not even half of it. This is like maybe a quarter of it. This is just when I first started. A lot of this high voltage stuff, I've been doing this for a long time, guys. I know exactly what voltage is going to do when you hit it on something. And you can see I twisted every which way. I think I burned everything. You see wires in there burnt. You see some DC flybacks on fire. And Sean, I played your favorite clip of my Tesla coil on fire, just smoking and just keep turning up the amount of energy going in. Guys, look, I do all these experiments for a reason. I want to know what voltage is doing. I want to know how to read it. I want to know how to connect it. And man, it's really awesome. Sean, thank you, brother. You didn't have to do that, man. Thank you. I really do appreciate that. Sean's building me a coil, man. Now let me tell you something. I'm going to validate every one of Sean's experiments with that Tesla coil. And then I'm going to show you what it's really going to be able to do. I'm going to force that thing to do everything in the world. So you see all the tests I put a ZVS through and a DC flyback. Wait until I get that Death Star coil, man. That, round Tesla coil that he's got that looks like a old school, bomb. And yeah, that's what I'm going to do. We're gonna get it going, man. I'm going to rip that thing with AC too. I want to see those purple tendrils come out. So, yeah, try to get to the electro boom sometimes, man. Well, you never know, man. Dude, if I showed you all the tapes that I got shocked in, it would be absolutely hilarious. I think I cut most of them out and deleted them because I was embarrassed that I got shocked so many times, man. But it happens. I mean, look, I got nailed with some pretty nasty voltage. And, yeah, a lot of the experiments I do, I should put up a warning on them and say, don't try this at home, or make sure you turn off the power before you hook this in. But, hopefully all you guys out there understand, that I do that. And sometimes, man, you have unfortunate accidents. You walk by something and it gets you. You're not expecting it to be on. You forgot to turn it off. You say, well, how do you forget to turn off high voltage? Well, you see it. It doesn't look like anything. And then you turn off the lights and see all the purple. Well, do that a couple times and you don't realize that it's on. You put your hand in between. Ooh, you complete that circuit. That's never fun. I've done that several times on accident. Never meant to, but I did. They say use the pocket pull rule, or I'm sorry, the one hand rule. So yeah, that's what you got to do here. Yeah, good times, man. Yeah, please like and subscribe, man. Awesome. Just awesome. Sean, you're an awesome guy, brother. Glad the surgery went well for you today. Yeah, RF burns stink. I get a lot of those. Yeah, you blow up a lot of testing equipment, man. People don't realize you go through a lot of it. And it's not because you want to. Trust me, I don't want to break everything. I love it to run forever. It just happens. Some things just get worn out. Yeah, well, I can tell you this. I'll do this again next Monday, guys. But I'll show you the next part of my journey because it gets better. We start to realize, okay, we go from old man builds blowing up ZVSs and doing flybacks to I really started cranking into Tesla coils and what they're actually doing, not what you think they're doing. So we'll show some one-wire energy. We'll show some more voltage coming out of it. We'll do a lot of DC in there, man. And I'm telling you right now, it's going to be completely confusing the first time you watch it. You may have to watch it twice. There's a lot of nuance to what I do. As you see in the flybacks and stuff, there's a lot of spacing that's important. And I'm really, when I get to Tesla coils, I'm forcing resonance to work for me. You see, resonance doesn't just work on the regular scale. It works on the Planck scale. It works on the micro scale. It works all of it. It goes right through all of it. It is your connection to everything in this world. Now, when you do that, just understand this. I'm going to force fields together, then I'm going to blast them apart. So that's going to be cool. Let's answer some questions. What do you think changes in the one wire when it switches from DC to AC? Okay. Let's see. In the one wire energy, just understand this. We're forcing everything into that rod that goes down the center. When you do that, nature pushes back. It says, okay, I don't like to be forced together. I want to break out. So what it does, you force it in, it breaks out into a bigger field. That's exactly what it's doing. You're forcing it on the Planck scale to have the resonance, forcing it in there. Then boom, it blows apart. Now, how do you field flip that? It's a very simple process. You have to change the amount of distance between the center rod and the Tesla coil itself. So you get a smaller Tesla coil, small diameter Tesla coil, changes the distance. Now, you can also improve the size of the rod in there. That'll change the distance as well. It changes how the transformer works. Normally air core, now you're putting in something that's more of a solid core. So you want to take it a step further. Take an insulator, like a tape, just electrical tape, shrink tube, something like that. Put it around a copper pipe. Now keep the distance 1/4 inch from the Tesla coil inside pipe. What you're going to get is just a total field change. It won't be anything like one wire energy. It'll be hot energy, ready to go. I've done it with a Tesla coil inside of a Tesla coil with a pipe inside of another pipe. And let me tell you, if you do that one right, and you can match frequencies in that, you got something going on that really should never be shown on YouTube. And on the opposite side of that, man, it makes a thruster. Ion wind is nothing compared to this thing. So it all depends on how well you know resonance and how much you can match frequencies, how much you can impinge them, how much you could force them together on that smaller scale. You know, it really takes some doing and some understanding to go there. And the material you choose is absolutely important. Aluminum is better for a laser. You know what I mean? Brass is better for non-sparking and stuff like that. You can see it through your thermal cam. That's the one thing I have to do is when I do that to show you that. By the way, I just want to mention this. And we've seen Hutchinson do this, and I just want to tell you, he's the king of this stuff himself. Crystal doesn't activate under high voltage. I'm just going to tell you, it goes right around it. It goes from anode to cathode right around it. But if you put a piece of crystal in, let's just say a drill bit connected to it or hits it and puts pressure on it, it'll light up like a Christmas tree. Yeah, beautiful display, but it's under pressure. That's why it's doing it, and it's creating miniature sparks as it gets rubbed together. It's that force that's rubbing them together to create that spark. It's no different than how your your barbecue lighter works. It's the same thing. It's just putting them together to get that spark, right? We've seen people out there with rocks starting fires, with sticks, just like this. It's the same process there. High voltage does not communicate with crystal. Water and frequency communicate with crystal and the one-wire energy. You see, it's a radiant energy. Crystals are radiant energy. They trap it in. Then you can watch any crystal video that has a good sense to it. They'll tell you there's radiation to make those crystals. So when we're talking radiant energy, it's a lower form of radiation. So it interacts with it. How do you communicate with it? Well, it has to be in the water. And I can tell you that from all the one-wire experiments I've done. That's how it communicates. Yeah, you saw it glowing orange. I'll tell you why. Because light on the outside when high voltage sparks over, remember the DC experiments I did? Every single one of them, I told you a different color that was coming out of it. Well, put in a certain amount of amps and creates a color. The crystal itself refracts that light, and the crystal will light up. It's no different than putting a laser to it. Put a laser to a crystal, I guarantee it'll light up the color. That's how it works. It's refracting light. So that's how you see it glow. Now, you say at 2,300 Fahrenheit. Well, we'll find out. We could throw one in, I don't know, what you get there, a torch or something? So I'm just telling you the way I've seen it happen. And I've hit this thing with every bit of high voltage that I could. And I've never gotten it to glow unless it's with frequency and water. That's it. It's the only time I've seen it done. I could show you videos of Hutchinson do it. It goes right over the top of it, goes right around it, and it glows, but it's glowing based on refraction of light, not because you activated the crystal itself and the crystal itself is putting off the energy. There's a big difference in that. You can make it glow, just put a laser to it. It'll glow any color the laser is. But if you really want to activate it, that's when you got to use water and you got to use radiant energy. That's my opinion on it. I could be fully wrong. If you got a video to prove me wrong, I'd love to see it. Send it to my email, and I'll absolutely put it on the channel, and I'll eat my words if that's what's going on. Let's see. Piezo at 40 kilohertz is supposed to create that in water. Well, we'll see. The piezo's crystal, so it communicates with crystal. That makes all the sense in the world. Why not? I was talking to somebody, and they're trying to run piezos at a very high level. Can't put too much voltage in them. Can't put too much amperage in them. They are a low-level circuit. But they amplify energy. So if you have radiant energy, it'll amplify it. If you don't have radiant energy, there's no amplification. You're missing something if it's not working. If you keep breaking them, you should learn your lesson. You want to create the weak fields, not the strong fields. They have to be able to sync with one another. If you create a field that's too strong, then the frequency of the other field opposing cannot match it because this is overpowering this one. So it'll just block it every time. You got to think 3 weak fields. Why are they working together? You are creating 3 points of resonance. The resonance is the key to everything. 3 points of resonance in weak fields creates the effect you're looking for anti-gravity. I could say this till I'm blue in the face, and I still don't think people understand it. Oh, Pat, put a bunch of voltage in it. Put a bunch of voltage in it. It's just not going to work. I've done it. Dude, I roast things. You can see that from the stuff I did today. I roasted hard. Okay, I could throw as much in there until I blow everything up, and I have. But they communicate only on a very low level. Then the field it creates, wow. Now you got something. 3 weak fields makes one tremendously strong field. It's the resonance that's pulling in the energy. You see, anything that resonates at that same frequency produces the energy. I could set off one of my Tesla coils and the 3 behind me will light up with plasma. Why? They're just wound to the correct resonance. That's it. Now think of that when you take 3 weak fields and now they can communicate with resonance with one another. Now you have something on a total different scale. Now you're playing with the big boys. Do it in the heavy field starting out, too much magnetism. Forget it, you're done. Too much voltage, you're done. Keep going, man. What do you got next? Frequency? Wrong frequency. Passes like 2 ships in the night, man. They don't even see each other. They don't even communicate. They completely ruin the whole experiment. Get the resonance to each system correct. Do not overpower any one system. The amount of energy comes from the combined 3 together, not from each individual one. The power comes from the 3, not the 1. If you overpower one part of the system, you fail. Van de Graaff generator for static electricity in that system is a failure. Complete failure. You overpowered it. You didn't hit the right fields. Sorry, not working. I've done this too long, guys, too many times. And I'm going to tell you that's how it works. Anyway, With that said, man, love sparking things over. Oh, Sean, you should really rewatch this one, man. This is like high voltage all day, brother. So, oh, several other people in there. Like I said, dude, just give me the video. Like I said, I'll eat my words. I will eat them completely. You know what I mean? If that's what's really going on. So just send me the video, man. I'd love to see it. I'd love to be wrong, because then I would repeat the experiment to find out. Yeah, I learned so much how to dial it in. Yeah, Sean's got a real good process to dial things in. Yeah, you know what? All that time put into, you know what I mean, getting different effects to work. You know what I mean? That's awesome. Yeah, Sean said he'll eat his words with you. Yeah, Sean and I talked about this a lot, man. Because, look, if you get crystals to light up, let me just say this, just so we all understand each other and where we're at. The Ark of the Covenant had crystals that light up on the metal plate the monk wore. Now, he didn't have electricity to the plate. He didn't have anything. It was a plate with crystals in it. Yet each one lit up individually as this thing was running. The only way to do that, from what I understand, is have that frequency in water. The water pushes the field out. Now, that's all I'll say. I don't think that monk had super high voltage, super high heat on him. It would have killed the guy. So it's biblical when this happens. When you get that crystal to light wirelessly in any field, you have created something that the Bible tells you happened. I want to see it. That's when you know you got it. That's all I'm saying. You know what I mean? That's it. Well, let's take a look. He said it's on his page right now. So let me see if I can. Oh, let me see. Give me 1 second, guys. I'm going to flip this over and I'm going to pull his page. Okay. Okay, tell me which video it is. We're on your page right now. You got to send a link to my email or just tell me which one it is. We'll start looking through. The orange orbs, or blows up on the starting line. Let's see if he's got any shorts. UFO, you have bright orange. Okay. This was 100 feet over your house? Where is the crystal in this one? Let me go full screen layout, guys. I see the light on the top, how it shoots off. Is there any music on here? Just so we know. So let me get this right. Sorry, I'm trying to catch the moment where it's up. There it is. Okay, so that's what we're looking at. And you're telling me the crystal discharged this voltage? Is that what I'm hearing? Okay. The beginning is the UFO sound, and then you can hear it moving. Okay. Yeah, I paused it, so I slowed it down. It was surrounded in flames. Interesting. Huh. Okay, well, let me see if I can't change the speed on here. I don't think I could change the speed on this one. Okay, so this is flames. Okay. I thought we were going to see the crystal lighting up. Okay, I'm sorry. I was looking for a crystal discharge or something. Let's go ahead and play it a little bit. Yeah, we definitely hear the buildup and discharge. Well, I'll tell you, that's definitely interesting, man. That's cool. You say it's a Lou Alzido and okay, I'm just gonna leave those words alone. Some kind of diamond, but it's quartz. Okay. It's not a craft either, it's some kind of motor. Yeah, the shorts don't give us the same control. All right, man. Well, I believe you that that's shooting off. I believe that's 100% authentic right there. I was kind of hoping to see the crystal itself and see it glow. You know what I mean? As it went off, you kind of off camera a little bit for that one. But that's cool. I do like it, man. That was awesome. Yeah, it's a bunch of people. Yeah, dude, I believe you. I believe that whatever we're shooting off is 100% authentic. We're all there with you. I think every one of us are. Right on, brother. Well, thank you for sharing that, man. I do appreciate it. That's awesome. I love any kind of voltage, man, especially things that just aren't normal. Yeah, I would be too, brother. You want to see it again real quick? Sure. Okay, check it out. Sorry, I paused it again on you. I paused it because the timing of it is very specific. It took me a while to find it the first time. After that, The timing is 100% like every time. It'll build up discharge, build up discharge, build up discharge at the exact same rate every time. Huh. That's cool. You can hear it. Watch. It'll build up and discharge. So we filed a report for MUFON. That's the UFO agency that researches this type of stuff. Yeah, President confirmed it. Yeah, I believe it. Wow. I've never heard the president say shot down 3 UFOs, but yeah, I'd like to see that announcement. But I do believe you that absolutely it's real. Yeah, it's the same frequency every time, isn't it, Sean? So, I'll just mute it here. I'm going to tell you about something about frequency because I'm mostly deaf. I'll do frequency experiments in my garage. I won't hear the frequency, but if I do it live, you can hear all the frequencies and all the changes. I can't hear them. So I don't doubt that you're standing right next to it and can't hear it. But when you put some kind of microphone there, the microphone picks it up. So, yeah, I've done that a lot, man. And I thought it was just because I can't hear. No, it's not. Everybody else couldn't hear it either. It's only when you put the microphone there. Yeah, there you go. Man, that's awesome. Wow. That's just really cool. UFOs, man, you gotta love them. They don't come to my house, though. I don't know why. I didn't even want to ride it around the whole place, man. Yeah, you won't see me for a while. I'll be doing my show from a UFO, man. Trust me. I have zero fear, man. Let's do it. Was it in a state of awe when you recorded? I bet you were, man. Something like that going on? So it definitely looked like it came from the ground and went into whatever was flying above. So you say there's a ship. It definitely flew into it. Yeah, it makes sense. One in 53 years. Wow. Well, I hit 48 today, guys. So maybe one before I'm 53. That would be cool. Right on, man. All right. So anyway, guys, next Monday I'm going to do a little bit more of, how I got into all this stuff and a little more of, some Tesla coil stuff that we're going to be doing, different experiments that I did to show you, hey, this is how I started in this. Like I said, I don't think a lot of people know that I did high voltage before we started this show. So I just want to make sure everybody was aware of it, make sure everybody aware of what I did in Tesla coils. So you understand, I'm pretty well versed in all this stuff. So right on, man. Thank you, Sean. Hanging out with all my friends on my birthday. That's awesome. All right, guys. I'm going to play a clip right quick. Just kind of my own little ad thing. I should have done it halfway through, but I was just having fun watching voltage. So we'll pop that up real quick for you guys.
In a world consumed with big words to describe simple things, a voice for the people arises, not afraid to tell the truth, not afraid to be wrong, and defiantly not afraid to meme the shit out of people, even himself, if the time calls for it. He is the old man builds. He asks for your humble participation in his channel by becoming a member. Now you can throw up the emoji that sticks it to the man, or just asks, what the F? But don't forget about his Patreon, all the PDFs you need for anti-gravity, free energy, and the understanding of harmonics. All the links will be in the description, including Old Man Bill's new podcast channel. It is time to break through the physics jibber-jabber and finally get this done. Let's effing go.
That's so cool, man. Gotta do a little promotion for myself. Yeah, I'm old now. Huh. Right on, guys. Hey, thank you everybody for showing up today and hanging out with me. I do appreciate it, man. Let you eat cake, yeah. Nope. Too much sugar, man. Huh. Maybe give me some greens or something. Those are really good. So my wife made some ham hock and beans, man. I wish she would have made some collard greens with it. That would have been really good. So, oh, what on, man? Hey, I'll get with you there and we'll talk about that story a little bit more. Maybe we'll do a deep dive on it in the channel, man. So, all right, guys, thank you very much for watching me today. I appreciate it, guys. You guys are awesome. Thank you very much. And have yourself a great day. If you get a chance to be a member, man, I'd love to have you. All right, guys. Talk to you later.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.